This diagram shows a wedge of mass 8 kilos, all of whose faces are smooth, resting on a smooth horizontal table. One of the faces makes an angle A with the table where tan A is 3/4. The other free face is vertical. So here's my A. My A and tan A, 3/4. Cos A is the O part, so the A part's on the bottom, so cos is the A part, 4/5, and sine A, 3/5. So at the top of the wedge is an attached smooth light pulley. So this guy here, T and T being the tensions in the string. A light inextensible string passes over this pulley, connecting particles of mass 5 and 1. Here's my 5 and here's my 1. As shown with the 1K mass against the vertical face of the wedge. So it's touching here, so there's going to be a reaction going on in this way. So what are we asked to do here? We're asked to form 5 equations. When the system is released from rest, the 5K moves down the inclined face with acceleration F relative to the wedge. The wedge moves to the right with acceleration A. Write down 5 equations of motion, everything we've been doing so far, answering the following 5 descriptions. So it's just a different way of phrasing the question. 5K on the inclined and the perpendicular, the 1K on the vertical and the horizontal, and the wedge on the horizontal. Okay, let's look at the 5K first here. Yeah, my 5K. So 5 kg, so we just got, so coming down mg, 5g. We've got my ore, I'll call it ore1 with different ores, ore1. We've my angle A. So coming down this way with my angle A inside, I'm going to have 5g cos A, so 5g by 4/5, I'll just do a bit of rule for it. 5g by 4/5, you can see is 4g, and in this direction here it's going to be 5g by 3/5, it's going to be 3g going down in that direction. My acceleration, they said, was F relative to the wedge, and A for the wedge. So A, so I've got my right angle triangle, and I have my angle A here and corresponding to here. So over this side opposite A, I have sine, so I have 3/5A, so 3A/5. So the cos is on this side, 4A/5. So putting my T on, I'll set up my equations. So coming down in this 3g direction, this guy over here, 3g. The only thing opposing it is the T in the string, and that's equal to M, which is 5 kilos, times A. And we didn't write A down, but A in this case is going to be F minus 4A/5. Coming down this way and up this way, F minus 4A/5. So that is along the plane, perpendicular to the plane. We have this 4g minus R1 up here. That's equal to M, which is 5, and the acceleration we got here to be 3A perpendicular to the plane. 4g minus R1 is equal to 15A/5. So 4g minus R1 is 3a. We go on to the 1 kilo block at the side here, this guy. We have so we just have G going down, 1G. We have the tension in the string. We have this reaction here, which I'm going to call R2, in and out this way. We have acceleration, we're told, F going up and A going across. So we're asked to form along the vertical and the horizontal. Just know when we were asked the vertical and the horizontal. Vertical and horizontal. So we look at the vertical here. We're going to see that all we have going in the vertical is T minus G is equal to M, which is 1, times acceleration, which is F. So T minus G is equal to F. And horizontal, the only horizontals we have here are my R2. R2 equals MA, and the M again is 1 and A is A. So R2 is equal to A. I think that must be what we're looking for here. We're just asked to form the equations here. And then the last equation is the wedge. So we look at the wedge. I don't think we've seen what comes into play here with the strings at the top of the wedge. So let's just look at the wedge here and the forces that are going on first. So I have this string going down this way, T, and string going down this way, T. So we're going to be looking at horizontal and vertical. So we're going to need to bring in the value of T and up here based on our angle. And we look at that in the next part. We also have that reaction R2 that we said was coming from that side, and R1, which was coming from the particle. We have a reaction S between the wedge and the table. We have mg, which is 8g. So if we look at the individual components of this, if we look at this top part here with my t's, so I have t going down in this direction, and I have a right angle triangle, and t is my hypotenuse, similar to working out your accelerations and your R's. We have the angle A from down below, which you can see the alternate angle to A will be here. So I've cos along this side. So this side is going to be, what do we get for cos? Do we write that down? Tan A is 3 over 4, cos A 4 over 5. So we're going to have 4/5 of t along here, the top part. So 4t over 5 and 3t over 5, the sine part along the vertical. So that's the t part at the top of that triangle. If we imagine that, put the triangle underneath it and connect the diagrams, then we have the string going down up like this, for want of a better diagram. Let me just put in my 8g, my R2, I have t coming down in this direction, I have t connecting around with what's going on with t down the incline here, which gives me the 4t and 3t for the vertical and horizontal. Then I also have the reactions that are going on over here. So I've got R coming through here, R1, so coming down this way and going across this way with my angle A, sine at the bottom, and the sine of A was 3 over 5 over here. So this is going to be 3 or 1 over 5, and this one is going to be the cos, which was 4 or 1 over 5. So can we form our equation of motion? My acceleration is in this direction. What's going in that direction? This 3 or 1 over 5. What's opposing it? This R2 is opposing it. Anything else? Yeah, that's why we did our t's here. This one here, if you imagine the string pulling it back, 4t over 5 is equal to m, which is 8 times a, which is a. And I don't think we can do any more with this question.